So I thought I would do a little live here with some questions about enzymes. So if I were to be given this question, for example, it was to state that the equation shows the effects of enzymes on carbohydrates. And now I'm being asked to identify the enzyme involved. So first of all, I need to look at what they've told me. So they've got quite a few things here. So they're telling me that we've got amylose, amylopectin, and glycogen. So these are all polysaccharides. So straight away, I know I am going to be breaking down some polysaccharides. I can see quite clearly in the equation that they've told me that there is water present too. So in the exam, they would obviously write it as H2O. So why do I need water? Well, water is going to be useful in hydrolysis. So we're going to break down these polysaccharides into smaller molecules. Now they've also shown me that I've got an enzyme and a reaction. They've told me a bit of information. So they've told me about the pH, so that's interesting. They've also told me that I've got a chloride ion here. So what is it that is the name of this enzyme? This is an enzyme you should know, which is called amylase, because it's an enzyme, and the enzyme is going to be breaking down the starch or glycogen, the polysaccharide, into smaller monosaccharides. So it is always important that whenever you are doing this, you are looking at what the question is asking. So let's go on to the next question then. So the next question then says to me, okay, so explain the role of that chloride ion in this reaction. So they're expecting me to remember that if I'm talking about amylase, amylase is an enzyme. So we know it's an enzyme. So what do we know about enzymes? Well, we know that enzymes need to have active sites that are complementary to the substrate that they're working on. Now, I'm not actually answering the question at the moment. What I'm doing right now is I'm just giving myself some information to think about how and why this might be important. So this is an application question that they've given you some information and they want to see, do you actually know what it does? So what's the role of the chloride ion? So let's go back. Amylase is an enzyme. It's an enzyme. So then I'm going to add in a little bit of a note for myself to say that this is a protein. Now it's a protein that's got a, because we're talking about an enzyme, tertiary structure. Now we did say before that the active site needs to be complementary to the substrate. So because the active site needs to be complementary, why is chloride ions needed? Well, the chloride ion is a cofactor. So it's a cofactor that what it's going to do is when this cofactor binds to the enzyme, what it's going to do is it's going to change the tertiary structure, therefore making it complementary to the substrate. So what we're doing is that cofactor is required for the amylase to have the right active site that is complementary to the substrate. If there's no chloride ions present, it's not going to be able to break it down. So therefore, what's the role of the chloride ion? The role is that it is this cofactor, and that changing by binding to the enzyme, changing that tertiary structure, therefore makes the active site complementary. So it is important when you're doing these types of questions that you note what it is that they're expecting you to actually give them with information. So let's carry on and see how else we can apply our knowledge to this question. So the next question then says, okay, explain why this reaction does not continue in the stomach. So straight away they've given me in a question some information. Stomach, and they've told me it's a pH of 7. So therefore I should know that my stomach pH is acidic. Why is it acidic? Because you have hydrochloric acid that is released into the stomach and therefore changing the pH. So if I know that the stomach is acidic and I have been told that the pH is 7, this is my amylase enzyme, I therefore should know that I'm going to be affecting the pH. So if I were to draw a graph and look at pH, I know that my rate of reaction is going to change based on the minute I move away from my optimum. So if this is my optimum pH, what I know is that if I am moving away from that optimum, what's then going to happen, just put that up slightly, is we're going to end up with the denaturation. Well, what is denaturation? What do I actually mean when I say that? So remember, we're talking about an enzyme. So I'm going to go back and just remind myself that the enzyme is a protein that has a tertiary structure. And what I need to remind myself is that tertiary structure, what causes that tertiary structure? Well, this is because of interactions of the R groups. So that could be hydrogen bonds, it could be ionic bonding, it could be disulfide, cannot spell, let's try that again, disulfide bridges, and it could also be hydrophobic, hydrophilic interactions. So what you have then is the fact that you have these different interactions of the R groups which are causing that tertiary structure, and reminding yourself that that's a 3D shape, that tertiary structure. So what that's going to then do is that's going to be affected by the pH changing. So if the optimum pH is 7, as it's told you in the question, and it's moving away from the pH of 7 down towards the pH of 2, which is what you find in your stomach acid, what you're then going to find is that change, that denaturation. You have got that the tertiary structure changes, and therefore, because the tertiary structure changes, the active site is not complementary to the substrate, and therefore the rate decreases. So it is important when you're looking at these sorts of questions that you note what it is it's asking of you. And I've seen quite a lot of videos that say about these command words. This is explain why this reaction does not continue in the stomach. Explaining it means that you need to be mentioning the changing of the shape, the pH being away from its optimum, therefore affects the tertiary structure. That therefore means that active site is no longer complementary and the rate will be decreased. So it's really important as you go through any type of question when it comes to enzymes that you are looking at how to maximize the information that you're giving to the examiner. So what I try to do whenever I do these questions is I always try and look at what it is that I've been given in the question and use that to guide me on what's going on. So this one, again, a command word, explain the shape of the graph. So a lot of students will see this graph and automatically go, oh, the rate is increasing, and then it's plateauing off. But this question, that command word, explain the shape. Tell me what's happening scientifically. What is actually happening between A and B? Why is it that the rate of the reaction is increasing? So it is important when you do this, you're looking at the fact that actually we're using a term that is, whenever you've got a graph, anything before a plateau, I always tell my students that that is your limiting factor. So we have a limiting factor here. The fact of the substrate, there's not very much substrate. So if there's not very much substrate, that therefore means, what are we talking about? Ooh, we're talking about a rate of reaction. We're talking about enzymes. So what do we know about enzymes? We know that enzymes are proteins. This is my enzyme. Let's try that again. Here's my enzyme. So there's my enzyme. We know that that enzyme has got a very specific shape and it's got its active site. We know that that's because of the tertiary structure. We also know that it's got a substrate that it will work on. So if this is my substrate, so there's my substrate, there's my enzyme, that's my active site. Well, if I have, let's say, 20 enzymes but only one substrate, the rate of reaction is going to be lower. Why? Because some active sites are free. The substrate was limiting the rate. There wasn't enough substrate for the enzymes to be working on. So that's going to limit the rate in which the reaction can happen. If I increase the substrate concentration, more of my active sites are going to be filled. So therefore, increasing the substrate concentration is therefore going to increase my rate of my reaction. So when it says explain the shape, I'm explaining it because I'm talking about the active sites and the fact the active sites are free when the substrate is a limiting factor, and that if I increase my substrate concentration, I'm going to increase the rate of reaction. We can see that quite clearly. We've gone from A, which has a lower rate of reaction, to B, which has a higher rate of reaction. So now we need to look at C and D. Well, we're no longer talking about our substrate concentration limiting the factor of the rate in this reaction. So what is it that's going to happen here? If I increase the substrate concentration, remember my enzymes, I only have a set number. I said, if I remember rightly, I had 20 enzymes. Well, if I increase my substrate concentration, the minute that my active sites become filled, that therefore becomes the limiting factor. So the number of active sites available is limiting the rate. So the active site numbers now are limiting that rate, and that's why it starts to plateau off. So it doesn't matter how much substrate I provide to the enzymes, I can keep bombarding them with more and more substrate, but if the active site is already made a enzyme substrate complex, so if this is my enzyme and we have a substrate and we've got our enzyme, if I've already got an ESC, an enzyme substrate complex, I can't get another enzyme substrate complex. I have to wait until the enzyme substrate complex has done what it needs to do, turned into the enzyme product complex, then release the product out to then be able to collide with another substrate to successfully cause the rate of reaction to increase. So it is important when you're looking at those words, explain the shape, explain the science that's happening as to why that rate has stayed the same. What is it that's causing it not to increase? So number of active sites available is the limiting rate. So we have the number of substrates exceeds the number of active sites. Therefore, the rate doesn't increase. So it is important whenever you're doing these types of questions that you are looking at how you can apply your knowledge. Okay, so I'm going to give you another random one here. I just thought I'd jump on and do some questions. So here's another random question for you. Let me move that up slightly. So they've given us a completely different bit of information. This is kind of year 13 content and application. So what we have is we have an enzyme controlled steps involved in the synthesis of noradrenaline and adrenaline. You've never been taught that. You won't be taught that because you don't need to know it. But what you do need to know is that everything to answer this question is right in front of you. So what they do when they give you these types of questions is they're trying to see, can you gauge the information from what's in front of you? Well, the first one isn't. The first one is just literally asking about, what does the term metabolic pathway actually mean? Well, we're talking about a pathway. A pathway is linking things together. So what we have here is we can quite clearly see the tyrosine is going to be turned into dopa. The dopa is then going to be turned into dopamine. The dopamine can then be turned into noradrenaline. The noradrenaline can be turned into adrenaline. How? How is that happening? It happens because what is the arrow representing? My arrow, whenever I see an arrow, I know that that is representing that there are specific enzymes required. Because this is a enzyme controlled step, we're being told already in the question. The arrows represent specific enzymes required for the reactions to occur. So therefore, what is a metabolic pathway? It's a specific series of linked reactions. Each of them, each step requires its own specific enzyme. So whenever you look at a question like this and they're asking you to give information, it is important that you note, what have they already told me in the question? And I love that about exam questions. Sometimes they're difficult and you can't figure it out, but sometimes you can work it out. So let's keep going with another type of question that they've asked linked to this. So here, same equation. I've not changed it. I've not changed the pathway. But now what they're doing is they're saying, okay, we want you to specifically look at the action of the enzyme which is involved in the conversion of dopa to dopamine. I've never known this. I've never done this. My teacher didn't teach it to me. Well, actually, they taught you something. They taught you something that's very relevant here. And this, again, is where some students miss out in the application process. So we can quite clearly see that we have a molecule, dopa. That molecule dopa has been turned into a new molecule, dopamine. So this would be my substrate of this reaction. This would be my product. So there I've got my substrate, I've got my product. Now what I'm looking at is, well, what's happening? What's happening here? Oh, it's quite nicely demonstrated. It's removed carbon dioxide. So what is the action of the enzyme which is involved in this conversion? What they're checking is, do you know that you have got carbon dioxide has been removed? Well, what is carbon dioxide removal? Well, removal is D. The answer to the last question, I've got to remind you, what's a metabolic pathway? The metabolic pathway was a specific series of linked reactions with specific enzymes. So if I say this is enzyme number 1, oh, hold on, I'm on the wrong one. Enzyme number 1 enzyme number 2, enzyme number 3, enzyme number 4. It is a series of reactions that are all linked together. One, then the other, then the other, then the other, then the other. So you will have looked at metabolic pathways when it comes to respiration. So when you're looking at respiration, you've looked at the fact that it goes glycolysis to the Lynch reaction, to the Krebs cycle, to oxidative phosphorylation. So therefore, you have got a metabolic pathway because it's a linked series of reactions that have got specific enzymes that are required for specific points. So this question, everything you needed was in front of you. And this is like really old style questions that I'm doing a few videos on old style questions because I think they're really relevant for how to apply. And a lot of you keep saying to me, how do you do the application? You're memorizing the content, and I'm putting those videos of the content on my YouTube channel if you haven't seen it already. Let me move that down. The Biology with Christine, that's got the content for you, and I'm still building those videos. But this is about application skills. This is about how you apply your knowledge to a specific situation. You're very welcome. So going back here, what is the removal? Decarboxylation. So therefore, what we're looking at here is we're looking at the decarboxylation of the molecule. Oh, I've lost my cursor. There we go. And that is linking to your knowledge. Although this isn't asking specifically, do you know this? What it is asking is, do you know that if you took your 3-carbon molecule and you were to change that to the 2-carbon molecule, so you're going from the, oh, there's me writing the wrong word. Let's try that again. Pyruvate. And that's going to become the acetyl group. Do you know that decarboxylation occurs there? So if you're looking at the Lynch reaction, for example, it's decarboxylation. Well, it's the same thing here. We're going from dopa to dopamine by removing the carbon dioxide. So it's really interesting when you get these types of questions, because what they're actually checking is, do you know the content, and can you then apply the content to the situation? Okay, so same question. I'm not moving on from this question yet. What I want to do is I now want to look at what it's giving me, because it's giving me a random bit of information here again. So this random bit of information, oh, let me use a second. If I move this down here, that'll be better. There we go. What it's telling me is I have enzymes that are involved. Those enzymes are going to be changing different products, changing different substrates to products, and then that product becomes a substrate of the next enzyme. But in this question, it's a really interesting one. It's actually stated that you require a phosphate here. Now, this isn't the type of question you would get in the exam. However, I think this is a really interesting question, because then it helps you, if you're year 13, to understand how phosphorylation, not talking about phosphorylation making ATP, I'm talking about phosphorylation and how that affects the regulation of protein synthesis, i.e. the regulation of your genes being expressed. So what does a phosphate do? So you should know that your phosphate is free in the cytoplasm. Now, if you have a phosphate is actually a cofactor if it binds to an enzyme and therefore changes its shape. So a cofactor is an inorganic ion which is going to bind to an enzyme, and that's therefore going to change its tertiary structure. By changing its tertiary structure, what's going to happen? That is going to give it a complementary active site. shape. So this was very much a application question in that it's looking for, there's me putting all the answers behind me. Let me move me out of the way. So what you've got is that it's application. It's expecting you to apply your knowledge to the situation. So you could say the same thing here. If I talk about methylation, what is methylation? Methylation is the adding of a methyl group. Now, by adding a methyl group, that's going to change that noradrenaline into adrenaline. So a lot of the time, they are giving you little hints. You've got dopamine oxidase here. So what's happening? What does the oxidase do? Well, it's not removing, it's adding. And they've given you a hint there. They've told you there's oxygen and the arrow's going in. And then there's another one where they've actually said, okay, we now have, and it isn't in the question, but it's a thinking about where these questions could go. You've been told that noradrenaline negatively feedback on this one here. So noradrenaline is a negative feedback on tyrosine oxidase. So what could they ask me to apply my knowledge? Because they've shown me a metabolic pathway. They've shown me that there's a negative feedback. And what is negative feedback? So reminding myself, negative feedback is where I'm going to reduce the magnitude of whatever the stimulus may be. So if I'm going to reduce the magnitude of the stimulus, in this case, the noradrenaline is going to inhibit the production of itself. And therefore, we could say that noradrenaline could be what's known as an end product inhibition. If there's too much of the noradrenaline, that therefore needs to slow down the production of the rest. So it's about where they could link things together and where they could push that knowledge when it comes to enzymes. So I just thought I'd jump on here, do a quick session on some application skills. So I hope you guys have enjoyed it, and if you have any questions, then please do feel free to ask. I can probably give another 3 minutes or so, and then I need to go off and do some more stuff. But if you have any questions, please do feel free. Oh, you're very, very welcome. I am going to try and do more of these. I've spent a lot of time on the course content for OCRA, but I do want to start doing more of the actual application skills. These are what I do in my group tuition sessions, but I do feel like for some of you, you've not been getting access to that. So I thought if I have a bit of time, I'll jump on, do a quick session, and hopefully you will find it helpful. But if you haven't, please do check out my YouTube channel. That has all the content up to 6.1.2, I want to say. Yes, I do. My group sessions are on, they're actually on Zoom webinars. And so, yes, I do them on a Wednesday night on Zoom. And then when I finish there, I tend to jump on here to offer some help for those who need it as well. But yeah, my group sessions are done on Zoom, which means that it is very much you get a pre-session activity. So these sorts of questions I would have given you to do 3 days prior to the session. And then what happens is you then do that. I look at all the answers that come in, and it means that I can see any misconceptions you might have. And then I go through it in the actual evening, not only with how to answer it, but I also go through some course content. So this week's tomorrow is on photosynthesis. So it's very specific to photosynthesis questions and topics. But yeah, that's what I do in my group sessions. Does anyone have any other questions before I say my goodbyes? Thanks for being with me, guys. And I will try and jump on. I might be able to jump on again tomorrow about this time and do another session. I'll find some more application questions to do with you. So I hope you've enjoyed it, and thanks. Bye.